So let's see how this looks like in a top view. Again, in a top view, I'm going to see this surface, and this surface. So there's a total of 3 surfaces. That's how your top view looks like. I'm going to change the view so you can see the edges. This is how it would look like. So as I said, 1 surface, 2 surface, 3rd surface. Now how would this look in the front view? Again, 3 surfaces. 1 surface, 2 surface, 3 surface. If I click the front, that's how your orthographic front view will look like. Now if I want to see the bottom view, which is looking from down looking up, all I should be seeing is 1 surface. See, that's only surface that I should be seeing. I click the bottom view and that's all I see. Now if I want to see the hidden edges, if I do that, you see the hidden lines? I see the hidden lines of the steps above. So this is your 3D isometric view showing the hidden lines. Again, the right side, all I see is like this. I don't see any of these surfaces. Why? Because they are normal to this surface. So right side view, top view, front view, and this is all I need to manufacture this part. Obviously I will be even putting in the dimensions and placing it onto the sheet to show the different views all together, either in first angle projection or third angle projection. Now we are going to see a lot more examples. So what I will be doing is making a 3D model just like this, and we will see how the different views look like from the top, side, front, back. Now what I have created over here is a shape. I'm going to give it a thickness, and now the next thing I'm going to do over here is just chamfer out one of the edges and hit OK. So now this is another 3D object. Now we have to figure out how the top, front, and the side views are going to look like. I'm going to go in the view and turn on the edges so you can see all the hidden edges over here. So let's start with the top view. In the top view, what am I gonna see? I'm gonna see surface 1, surface 2. Now you have to know this is an inclined surface. I'm going to see part of this surface as well. So that will be surface 3. Am I going to see this surface? No. Why am I not going to see it? Because if I'm looking from the top down, this surface is at 90 degrees. So let's see the top view. So I see surface 1, surface 2. Now this is the inclined surface, and part of surface 3, which is this much. So are you getting it now? So I saw 1, 2, and part of this surface, which is maybe half of this surface, 3. Now when I am in the right side view, what am I going to see? I'm going to see this surface, which is 1. I'm going to see this surface, which is 2, and I'm going to see this surface, which is surface number 3. Am I going to see this surface? No. Why? Because it is at a normal. This surface, again, I'm not going to see it. Again, why? Because it is at a normal. So let's go to the right view. This is how your right view looks like. Again, surface 1, surface 2, and surface 3. So you understand how we draw all these different views. So it's really important. Now, you tell me, how many surfaces am I going to see in the front view? So in the front view over here, I'm going to see this surface and this surface, which is 2 surfaces already. Am I going to see that one? No. Why? Because it is at 90 degrees from where you are looking at. It's a normal surface. So let's see the front view. This is what I see. Again, 1 surface, 2 surface. That's it. Now in this case, I have already shown the top view, the front view, and the side view. Is it important to show the left side view or the rear view? Yeah, why not? Because the left side looks different from the right side. So in this case, you might want to even put in the left side view. So I'm gonna go there, and this is how the left looks like. That's all I'm going to see in the left side view. So I click on there. Now don't forget, you have to show your hidden lines. You see the hidden lines? This is 1 hidden line and 2 hidden line right there. Again, I would like to show you in a 3D which were the 2 hidden lines. One of the hidden lines was that, and the other hidden line was this edge. If I want to show the bottom view, what am I going to see? How many surfaces am I going to see? Now if you look at it, I just see 1 surface, but I will be seeing a bunch of hidden lines. Now let's go to the bottom view. See how it looks like? You see the hidden lines? So while doing your projections and drawings, it's extremely important you have to even show the hidden lines. Your view is not just going to be of the lines that you see. You are going to show hidden lines. You are going to show center lines, holes, circles, etc. Now what I want to do is make a hole on this surface. So I'm going to draw a hole on that surface. Basically, I start with a circle. I'm not showing you how I'm doing it, but all you have to do is concentrate on how the view is going to look and how it is going to update. So now in this object we have added a hole. Now how is that going to change our drawing? Now we have some more hidden lines. For example, if I look in the front view, you have 1 surface, 2 surface, and then you can see the hidden lines for the cylinder going down from here and from here. Now even your other views are going to get updated, like the side view is going to show the whole hidden lines as well, like you see over here and here. So it's extremely important you make sure that you show the hidden lines wherever possible. So this is one of the examples. Now let's see, maybe we'll do a couple more examples so you have a better understanding of how the orthographic views are done using the technique where I start with the 3D and make the two-dimensional models. In real life, the 3D model is going to be in your head, and then you have to sketch out the model and then make your orthographic views from there. So you have to make sure that you visualize really well when it comes to CAD designing, 3D designing. So let's get into the next example. Now this is where I'm going to create a bracket. Start with my tools. And I just keep clicking. This program is really easy, a lot more easier than using AutoCAD. So I've created my bracket profile. I'm going to give it a thickness. Now this is done. Now all I'm going to do is put in a few holes. I'm going to go to my view so I can see my hidden edges, and I'm going to start putting holes onto the surface. So if you see, I have created a hole here and a cylinder going from here. So if I go to my front view, I'll be seeing this surface, the one that you see is highlighted. What else am I going to see? I'm going to see even my cylindrical surface starting from that edge till this edge. So let's look into the front view. Looks like that. Now do not forget your hidden lines, which is over here. Now what are those hidden lines for? There are hidden lines because there is a hole, rectangular hole right there. And then you see how the cylinder looks like. You see the top surface and where the cylinder curves. Now how would the top look like? In the top you're going to see this base plate 1, 2 and 3. What else am I going to see? I'm going to see this top surface, this top surface. So that's total 5. And one more thing that I'm going to see is just the top of the cylinder. Am I going to see the side of the cylinder? No. Why is that? Because it is at normal. So I'll click the top view. This is what I see. 1 surface, 2 surface, 3 surface, 4, 5 and 6. Am I seeing any hidden lines here? No. So my hidden lines can be seen in, if I'm looking from here, in my left view, looking this way, I will be seeing the cylinder as a hidden line. So let's look into the left view. And you see that? I see this one, see second, and do I see anything else? No, but I'm seeing the hidden lines of the cylinder behind and of this hole, which is 1 and 2. Sometimes it's a little tough looking at it, but the hidden lines are right there, 1 and 2, and the cylinder is 1 and 2. Going to go back to the 3D view. Let's look in the right view. The right view looks like this. I will see the cylinder as a solid line. Why? Because I see it in this view. I see this surface and I see that surface. What about this hole? Hole I will be seeing as a hidden line. So the hole that you see is 1 and 2. Those are the two hidden lines for the hole. And the hidden lines are shown always as dashed. So that was another example. So I hope it's making clear now how we work with orthographic projections and how we derive the different views. If I were going to go into the bottom view, I'll be seeing quite a few hidden lines. I'll be seeing the hidden line for the cylinder. I'll be seeing the hidden lines for these two brackets. And I'll be seeing this whole surface. So let's see the bottom view. So I see the cylinder hidden line. I see the bracket 1 and bracket 2. And obviously I see the hole. So that does with this exercise. Now let's look into some questions and answers. So the first question is, list the 6 principal views of projection. Now the 6 principal views are top view, front view, side view, which is right side, then left side view, the bottom view, and the rear or the back view. Now, what are the differences between the first angle and the third angle projection? Now, the main difference between these two are they are a mirror image of each other. These projections are basically how your drawing is set up on your sheet. In United States and Canada, we use the third angle projection, and in Asia, you use the first angle projection. Now all that happens over here is all the views are a mirror image of one another, and we already saw that example before. Now the next question is, how would you transfer depth between the top views and the side views? Now again, we work with our example over here. We can transfer the depth between the top and the side view by using our folding line and the miter line technique, where we just project these lines from the front view and the top view. Wherever it meets at the miter, we take that surface, bring it down, and we form a grid, and we just input our edges and get the final shape. So to get the depth in the side view, which is from here to here, I have transferred that depth by using the folding line and the miter line. So if you look, this surface goes all the way there, goes all the way down, and that's how I got this line. What about this one? Because this is the total depth. Again, the same thing, transfer it to the miter line, bring it down, and I got it over here. And how did I get it up to this height? because I already have my front view. So I just project my front view and I got that height as well as the depth. And over here I'm using the front and the top view, just using the technique which is the folding line technique, and I do that with the help of a 45-degree miter line. Now the next question would be, what angle is the miter line? Now you have to know the miter line is always at a 45-degree angle. Now another question is, what is normal surfaces? Now normal surfaces, which we saw in all our examples, like this is a normal surface, this is a normal surface. Normal surface is a parallel to the plane of projections. It appears true size and true shape on the plane to which it is parallel, and it appears as true length. Now when it was an inclined surface, does that appear as a true length? No, because you draw all the different views, top, front, right, left. In none of the views, if it is an inclined surface, you can get the perfect size and dimension. So for that, as I said before, you will have to use the auxiliary views. Same thing goes with the oblique surface. The true size is not shown in any of the 6 principal views, so you will have to use the auxiliary view technique to get the right size. Now what is an inclined surface? An inclined surface is perpendicular to one plane of the projection, but inclined to adjacent planes. The inclined surface projects an edge on the plane to which it is perpendicular. It appears foreshortened or shrunk on planes to which it is inclined. Now we saw the example of the inclined surface already. And if you would like to see it, I can always show you another example. For example, if I click that, and maybe I need a little bigger surface. Maybe let's do it to the cylinder. So if I chamfer the cylinder, see how it looks like there? Looks like it's chamfered at an angle. I could even cut it in half. I could do whatever I want, but right now it is perpendicular to one plane of the projection, which is this, and projects an edge on the plane which is perpendicular. So if I look in my top view, I still get the perfect dimension of the cone or the circle or the cylinder. Now that pretty much finishes this chapter, where we learned what orthographic views are, what are the 6 principal views, how to draw these principal views, what is the precedence of lines. Solid line precedes a hidden line, and a hidden line precedes the center line. Again, this is Tutor Ali, and thank you for watching my videos.